Hello, welcome to the Code Physics channel. Today we want to look at a topic known as moment over force. So sit back, relax and enjoy. Moment over force is defined as the turning effect of a force. In other words, this is the turning of an object or the turning of a body as a result of applying a force on this body. Okay, so moment over force deals with making a body to turn as a result of applying a force. In the figure below, we have a body, okay, that is labeled AB. That is here from A up to B. That is our body you're talking about, which is colored red. Then there is a force that is being applied onto this body. That is force F. It is going downwards, making the body to go downwards because the force is going downwards. Then we have another point here, point O. And this is the point where the body is going to be turning. Okay? So if I apply a force F on this body, then this force here is going to make the body to turn about point O. Now this point O, where the body is turning, is what we call the fulcrum, or it is called the pivot. Okay? Now, moment of force is going to depend on two factors. Number one, it is going to depend on the force that is being applied on the body. Okay? Then number two, it is going to depend on the distance from where the force is acting onto where the turning point is. Now remember that we said that the turning point where the body is going to be turning is what we call the fulcrum, or what we call the pivot. So if I apply a force on this body, okay, if I apply a force on my body AB, this force is going to make the body from point A to O to go downwards. Okay? Now, when side AO is going downwards, side OB is going to be rotating upwards. Okay? So, moment over force is going to cause a turning effect, a rotating effect of a body. As we can see here, if the force is applied here, it is going to make this body to rotate upwards. In other words, the side OB is going to rotate upwards. So our moment of force is going to be determined by two factors, like we've said. And number one, it is going to be the magnitude of the force. And number two, the perpendicular distance from the pivot to the line of action of the force. Now, line of action of the force is the line through which the force acts on the body. Okay? Let us consider the diagram below. If I apply my force onto my body, this is my body here. Remember that point O, we called it the fulcrum. So, if this is the force that is acting on the body, okay? Now, the line, the direction in which this force is moving. Okay, for example, if I push the body downwards, there is a direction in which the force is going to be moving. And this direction is represented by this dotted line. Now, this dotted line, or this direction in which the force is acting on the body, is what we call the line of action of the force. In other words, when you talk of line of action of force, it is that line through which the force is acting on the body. Then the perpendicular distance from the line of action of the force to the pivot is going to be the distance from here, okay, where the force is touching the body, up to the fulcrum. Now this distance, we are saying that it is perpendicular to the line of action of the force, because as we can see, if this is our line of action of the force, okay, it is meeting the distance at 90 degrees. They are always meeting at 90 degrees. And when two things meet at 90 degrees, then we say that they are perpendicular. In order to get the moment of a force, what we do is to multiply the force that is given to us with the perpendicular distance from the pivot, okay, to the line of action of the force. So in this case, if my force is given by F, okay, then the perpendicular distance from the pivot to the line of action of the force is equal to D. Then moment of a force is going to be given by force times the perpendicular distance, which is going to be the same as F times D. Okay, so moment of the force is always going to be given by the force times the perpendicular distance. Now the SI units of moment of force, the Newton meter. That is, we get the force, the SI units of the force is the Newton, and we are multiplying it by the distance, and the SI units of distance is the meter. Therefore, the SI unit of moment of force is going to be the Newton meter. So moment of force is therefore defined as the product of the force and the perpendicular distance from the line of action of the force about a turning point. Okay, so this is the definition we can give for moment of force. That is the product of the force and perpendicular distance from the line of action of force about a turning point. Now, moment of force is applied in our daily lives in so many cases. For example, let us take an example of a door. You find that the handle of a door is placed at the end and it is not placed at the center. For example, here, as you can see, it is at the end and it is not placed here at the center. Okay, now the other end of the door is where the door is turning. That's where we find the hinges. So you find that at this point here, maybe you have an hinge. Even here, we have another hinge. Okay, so at the hinges, the door is going to be turning. And me, when I'm opening the door, or you're opening the door, you're going to be holding the handle, which is at the other end, which is not at the center. Now, it is done like this because of one reason, that if the handle was at the center, in this case here, that means that I would use a lot of force. Okay? To open this door, you would need to use a lot of force. Why? Because we know that moment of force is the turning effect that is produced by a force. And we say that there are two factors which affect this. One of them is going to be the force that is applied, and number two, it is going to be the distance. So that means that if the distance is small, therefore you're supposed to use a lot of force. Okay? But if the distance is big, like for example in this case here, because it is at the end, that means that the perpendicular distance is big. So in this case, to open this door or to close this door, I don't have to use a lot of force. I use a little force. So it is for this case you find that the handles of the doors, they are placed at the ends and they are not placed at the center. A mechanic, when he wants to loosen a tight nut, he uses a longer spanner than a shorter one. Okay? This is because of one reason, that is that a longer spanner produces a longer perpendicular distance. Okay? And therefore, if the distance is long, that means that the moment of force or the turning effect is going to be high. It is going to be easier for him to loosen that nut. But if you happen to use a short one, it means that the perpendicular distance from the line of action of the force, okay, up to the turning point is going to be small. And if the distance is small, that means that the turning effect is going to be small. So in order to increase it, he has to use a lot of force. Therefore, if you use a long spanner, you're going to use little force. But if you use a shorter one, you're going to use a lot of force. Now let us look at some examples that involve moment of force. And our first example is reading. A force of 5 newtons is applied to a rigid body, to a rigid rod of length 0.5 meters. If the force is applied at the end of the rod, find the moment produced on the rod. So we just have to use our formula. Remember that moment is given by force times perpendicular distance from the line of action of the force. So I've been given the force, and the force is 5 newtons, and the distance, that is going to be the length of the rod. Okay, so that means that I'm going to say moment is equal to 5 times 0.5, where 5 is the force and 0.5 is the perpendicular distance. So from this we get that our moment of force is going to be 2.5 Newton meter. In the next question, you are told that a bull has a mass of 60 kilograms and he's sitting on a seesaw at a distance of 2.5 meters from the pivot. Calculate the moment due to his weight. Now we are going to use the sum formula, that is moment is equal to force times the perpendicular distance. In this case, we are using the weight. Remember that weight is a force. So we are going to use the weight of a bull. We multiply by the perpendicular distance from the pivot to where the force is. And this distance here is going to be 2.5 meters. Now we know that weight is equal to mass times acceleration due to gravity, which means that my weight is going to equal to 600 newtons. Now moment is the same as force times distance. In this case, it's going to be weight times distance, which is going to be the same as 600 times 2.5, and this gives me a moment of 1500 Newton meter. The next question is telling us that 3 forces act on a body as shown in the figure below. So we have a figure here and we are having 3 forces. Okay, there is a force due to the 40 kilogram mass, there is a force that is the weight 60 kilogram mass, and beside here we are having a mass of 313.3 kilogram. Okay, now the first question is telling us that what is the moment about O due to the 40 kilogram mass, and the second part is telling us what is the moment about O due to the 60 kilogram mass, and the third one, what is the moment about O due to the 313.3 kilogram mass. Now to get the moment due to the 40 kilogram mass, we are going to use the relationship moment is equal to force times perpendicular distance, as we are told. Then we happen to look at, this is our force, this is our mass, this is our mass. Therefore, we are going to ask ourselves, what is the perpendicular distance from the force to the pivot? Okay, now this is very important and you have to take good note of it. The perpendicular distance from the 40 kilogram mass is going to be the distance from where the 40 kilogram mass is, okay, where it is touching the body. Of course, it's going to be here, up to where the fulcrum is, or up to where the pivot is. So if I'm talking about the 40 kilogram mass, then I'm going to consider the distance from here, where the force is, or where the mass is in this case, up to where the pivot is, which is going to be point O here. Now this distance is going to be given by the sum of the distance from here up to here. They've told us that it is 0.5 meters. And then plus the distance from here up to here. Okay? Meaning that the distance from the 40 kilogram mass up to where the fulcrum is going to be 0.5 plus 4.5 meters. And in this case, it is going to give us 5 meters. Okay, so that's what we have here. Now, because they've given us mass, they've given us a mass of 40 kilograms. That means that you're supposed to change this mass into weight. And if I change into weight, that means that I'm going to get my mass and multiply it by the acceleration due to gravity. In this case, it's going to give me 40 times 10, which is going to give me 400 newtons. Therefore, my moment due to the 40 kilogram mass is going to be given by 400 times 5, which is equal to 2000 Newton meter. Now, force due to the 60, now moment due to the 60 kilogram mass, again you're going to use the relationship moment is equal to force times the perpendicular distance. Now, because they've given me the mass, that is 60 kilograms, I'm supposed to change it to weight, which is going to give me 600 newtons. Then I'm going to multiply this with the perpendicular distance. And in this case, the perpendicular distance is going to be the distance from here up to here. Okay? So we are going to get 600 times 4.5, which gives me moment as equal to 2700 Newton meter. Lastly, moment due to the 313 kilogram mass. Again, first of all, I'm going to get the weight of the body, which is going to be 313 times 10. So weight is going to equal to 313 times 10, which is going to give me 3130 newtons. So here, the perpendicular distance is 1.5 meters. The distance from where the mass is, okay, where the mass is touching the body to where the pivot is going to be 1.5. So we are going to be having moment as equal to 3130 times 1.5, and this one gives us 4695 Newton meter.